Welcome to the Math 1 lesson summary video for the task Pampering and Feeding Time. This lesson is a practice understanding task which takes the concepts you've been working on and applies them to new situations. The purpose of this lesson is to represent constraints by writing, graphing, and interpreting the solution set for a system of inequalities. So previously, Carlos and Clarita have been focused on the constraints of the space and the startup costs for their new business. Now they are going to take into account feeding time and pampering time. So for this practice task, we are going to be applying the strategies and skills that we've been looking at for the previous 3 lessons. And we're going to apply those skills and strategies now to 2 new constraints, which are the feeding and pampering time. When we look at the feeding time constraint, we see that the cats are going to require 6 minutes twice a day to feed and clean their litter boxes. So the cats are going to require a total of 12 minutes per day per cat. The dogs are going to require 10 minutes twice a day to feed and walk for a total of 20 minutes per day for each dog. Carlos can spend up to 8 hours each day, so up to 8 hours each day for the morning and evening feedings, but he needs the middle of the day off for baseball practice. When we look at the pampering time, they plan to spend 16 minutes each day brushing and petting each cat. So that's 16 minutes per day per cat. And 20 minutes per day bathing and playing with each dog. Clarita needs time off in the morning for swim and evening for her art class, but she can spend up to 8 hours during the middle of the day. So one of the first things that we notice is that our unit of measurement is different for these. So when we're talking about the time that it takes, the feeding time that it takes for the cats and dogs, we're using the unit of minutes. Yet when we're talking about how much time Carlos and Clarita have to spend on each of these chores, we're talking about hours. So right away I'm thinking we are going to need to either convert all of this to minutes or convert all to hours. But we'll get to that in just a moment. So the task is asking us to write inequalities for each of these 2 additional constraints, and we're going to graph them and then shade the solution set for each constraint on separate coordinate grids. So we're going to write the inequalities, and we're going to have 2 separate graphs. We can take a closer look at the information that we highlighted in the previous slide in regards to the feeding time and use that information to come up with some expressions that we can then put together to form our inequality. Remember, the cats are going to require 12 minutes per day per cat. We can write that with the expression 12C. The dogs require 20 minutes per day per dog, and that can be written using the expression 20D. We know that Carlos and Clarita have up to 8 hours to spend feeding the animals. And so if we convert that 8 hours to minutes by multiplying the 8 by 60, we come up with 480 minutes. When we combine all of these, we'll come up with our inequality. So we know that the total time that it takes for feeding the cats plus the total time that it takes to feed the dogs has to be less than or equal to 480. Now, if you think back to lesson 2 in this unit, we looked at a constraint and we wrote the algebraic equation to represent that constraint, and then we converted it to an algebraic inequality. And we discussed how the algebraic equation represented the boundary line, or all of the points that met the constraint exactly. So in this case, if we were to write this, use these expressions to write an equation, it would be 12c plus 20d equals 480. And that would represent the boundary line of our graph. The boundary line, again, is made up of all of the points, the combinations of cats and dogs, that meet the constraint exactly, that have an exact sum of 480. When we look at it in terms of an inequality, the inequality sign is telling us which portion of our graph is going to be shaded. That's also known as the feasible region. That feasible region, or that shaded region, contains the solution set to the inequality. In other words, it contains all of the points that represent combinations of cats and dogs that meet the constraint, that are less than or equal to 480 minutes. In order to construct our graph and construct that boundary line, we need at least 2 points. And we know from one of the previous lessons that we've been working on that there are different ways that we can do that. We learned how to select 2 points using the standard form as well as slope-intercept form. Well, if we put this into an inequality, again, we have 12c plus 20d is less than or equal to 480. In a previous lesson, we talked about finding the x-intercept and the y-intercept of our boundary line. And then once we had those 2 points, we could connect the points to separate all of the points on our graph that meet the constraint or that are too large, as well, or from those that are too small. We know that the x-intercept has a y value of 0. So the x-intercept is the point where our boundary line crosses that x-axis. If we substitute in the 0 for the y value, in this case, it's the dogs, and then we simplify, we find the x value, or the c, the cats, the number of cats, would be 40. So the x-intercept would be located at 40, 0. Similarly, we can find the y-intercept. We know that the y-intercept is always going to have an x value of 0, so we can substitute in that 0 for our x value. In this case, our x-axis represents the cats, and solve for the number of dogs, or the y-intercept. So when we simplify using our properties of inequality, we determine that the y-intercept is 0.24. So this is extremely helpful because it, again, gives us the points where our boundary line is going to cross the x-axis and the y-axis. When we look at that on a graph, it looks like this. So again, this is our x-intercept, and it's crossing the x-axis at 40. Our y-intercept is crossing the y-axis at 24. Remember, we have to use equal intervals when we are creating our graph, both on our x and our y-axis. We need to be labeling our x and y-axis. And then when we are determining which portion of our graph, which half plane of our graph to shade, we're interpreting the inequality. We know that the sum, or the combination of cats and dogs, has to be less than or equal to 480. We know that all the points on the boundary line represent points that are a combination of cats and dogs that equal exactly 480. So any points located above that boundary line would be points that are too large. They would not meet the constraint. Any points located below the boundary line would be smaller than 480 or less than 480, and those would meet the constraint. So we're able to determine just from looking at the inequality which half plane we need to be shading. Again, we're not going to be shading in the other quadrants, only in quadrant 1, because in the context of the story, it doesn't make sense to have a negative number of dogs or cats. So we're only using quadrant 1. If you're still struggling with interpreting the inequality in order to determine which half plane should be shaded, remember you can pick any point located below the boundary line and any point located above the boundary line, substitute those x and y values for the points into the inequality and see if it makes the inequality true. If it makes the inequality true, that means it's in the feasible region, or it is in the solution. It's one of the pieces of the solution set to that inequality. So for instance, if we took the point 0, 0 and we substituted that in to this inequality, 0 for C and 0 for D, we would have 0 plus 0 is less than or equal to 480. Is that true? Yes, it is. Because it's true, that means that the point 0, 0 is located in the solution set or in the feasible region or in the shaded half plane of the graph. Likewise, if we selected a point located above the line, for instance 30, 20, and we substituted those in for our x and y or c and d values, we would find that the sum of these products is not less than or equal to 480. Therefore, that point that we select above the line does not make the inequality true, so it's not a point that's part of the solution set. Next, we look at the pampering time constraint, and we can recall that each cat is going to require 16 minutes per day, which can be written as 16C. Each dog will require 20 minutes per day, which can be written as 20D, and they have up to 8 hours, again, to spend on pampering time. We can use the same strategy that we used for the feeding time. So we're combining or putting these together to form our inequality, and then we are locating our x and y intercepts so that we can place our starting points for our boundary line. We can connect those points. And again, we can write this in slope-intercept form if we prefer, or we can keep it in standard form, doesn't matter. And then we are determining which portion of our half plane we should be shading. Just like the feeding time, we know that the sum of our cats and dogs, the sum of the products of the cats and their pampering time and the dogs and their pampering time has to be less than or equal to 480. So we're shading all points that are less than or equal to the line that represents, the boundary line that represents all points that require exactly 480 minutes. And again, we could select a point that's below this boundary line, substitute the x and y values of that point in the inequality, simplify, and determine whether or not those x and y values make the inequality true. If they do, that means that that point is located within the feasible region, or within the shaded portion, or within the solution set of the inequality. If we select a point that does not make the inequality true when we substitute in the x and y values, that point is not located in the shaded region, or the feasible region, or the solution set of the inequality. Remember, if you need help on the Ready, Set, Go homework for this task, please check the Canvas student support videos.